So, students, now we'll continue with the chord. Theorem 5. This theorem 5 means it is written in your book in some other term like theorem 24, 25 in that serial. So you can just analyze that. That is, I'm just marking my explanation in 1, 2, 3, 4, 5. Like this, I'm marking the theorem. So theorem number you can find out from your books if you are having any confusion. So in this theorem, what it is saying? It is saying there is one and only one circle which passes through three given points not in a straight line. There is one and only one circle. One and only one circle which passes through three given points not in a straight line. Three given point not in a straight line. There is one and only one circle which passes through three given points not in a straight line. Suppose I'm just telling, just drawing the circle first, okay? Drawing the circle first. Here you can see, I am taking three different points. Let 1 point, 2 point, then another point, 3 point. These 3 points, let it A, then B, then C. A, B, C. These 3 points are not in a straight line. A, B and C. You can take it A point and this is B point, this is C point. These 3 points not in a straight line. There is one and only one circle which passes through three given points not in a straight line. So only one circle can be drawn touching these 3 points. So that's what I have done here. But we have to prove it. How will prove it? That is the main. The main thing is how to prove that these 3 points are in a straight circle, or the circle passing through the 3 points. So let the center of the circle is O. Okay. Now join these two lines AB and BC. And as I am showing you here, A, B and C. A, B and C. So now join this. So here this is 3 points. A, B, C are 3 points. So how to now these 3 points, if it is in a circle, now the perpendicular bisector. How will get the perpendicular bisector? take the rounder and more than half of this length of the AC line and this side and this side. And then keep the rounder here, this side and this side. Join this line. Sorry. This will be the perpendicular bisector. So the perpendicular bisector here. Okay. The perpendicular bisector means it will call through the rounder like this. It will take this line, one cut, and here one cut, then here keep the rounder, another cut, then another cut. Now joining this line, we are getting one point. So again, same BC. Take here, keep the rounder here, and take more length like this, and like this also. So now keep the rounder here, like this, and like this also. Now join these two. So you can see the perpendicular bisector of the line AB and BC. The perpendicular bisector of the point line AB and BC meet at a point. Let this point as O. So draw it here. So perpendicular bisector of this. Then perpendicular bisector of this. And just drawing. You can take the rounder and do it accurately. As you know, the perpendicular bisector of this is one chord and this is one chord. So perpendicular bisector of the chord always intersect at the center of the circles. So AB and BC, now we got the origin of the circle O, where the perpendicular bisector met. So origin of the circle O. Now OA and OB and OC. So what is this? OA, OBC, OB. What are these? These are all radius. So OA equal to OB equal to OC. So this is called the radius. That means these three, you can alternatively prove it also. Because the perpendicular bisect it in the straight line and it touches the line. Already before, in previous theorem, you have learned that it will bisect equally into the two half part and it bisect perpendicular bisector. So congruent triangle, from congruent triangle you can find out all this. From congruent triangle you can. So from here you can find out that O is equidistant from A, B and C. Isn't it? O is equidistant from A, B and C. O is the line of the perpendicular bisector. So OB equal to OC. That is what I am written. OB equal to OC, perpendicular bisector. So now you are getting that OA equal to OB equal to OC is equal to R. That is radius of the circle. So now O is equidistant from, you have proved what you have proved. This implies that O is equidistant from 3 point So this implies that O is the origin if a circle draw passing through point A, B and C. Got it? Now you have proved it. So O is the origin passing to the point A, B, C. Origin, if a circle is drawn passing to the point A, B, C. As it is equidistant, taking this equidistant, if you draw a circle, then this circle O will be the origin. And it is equidistant means this circle will pass through this. Got it? Now, perpendicular bisector of every chord always passes through its center. From here, there is one note, you can note it down. Perpendicular bisector perpendicular bisector of every chord of chord passes through the center of the circle. Okay? So perpendicular bisector passes through the center of the circle. Now, arc and chord. Equal arc and chord. Now you are getting, this is a circle. This is the chord A, B. Let the another point. Let it Q. So A, AB is the chord. AB is chord. Then A, Q, B is the arc. Arc of the chord AB. So arc of the chord AB. Equal arc chord, equal chords and equal chords chord equal arcs. Equal arc chords equal chord and equal chord chords equal arc. In a circle, if two arcs are equal, they cut equal chords. If in a circle, if two arcs are equal, they cut equal chord. CD can take another cut. You will fold it to the center. we will fold it like this, and if this AB equal to CD, if AB equal to CD, AB equal to CD, then we will fold the paper. Suppose draw the circle and cut this and fold along the origin diameter, and if it will what? It will coincide with O R C R D C R D arc CRD is equal to arc AQB. If we fold, then it will coincide. If we can cut, if we cut it along this after coinciding, AB line will coincide with CD line. If we fold like this, then AB line will coincide with CD line. As AB and CD are equal, so this part and this part will be equal. That is AQB and CRD. Will just cut after cutting the paper, we can match it. So both will be equal. So if a circle in a circle, if two arcs are equal, I told two chords are equal, then arcs are equal. It is in opposite also same. That is, opposite means if two arcs are equal, then two chords also equals. If two chords are equal, they chords equal arc. Two chords are equal, they chord equal arc. Then two arcs are equal, they chord equal arc, equal chord. Two arcs are equal, they chord equal chords. That is vice versa. So that is what I told you. And if arc of two equal congruent circles are equal, they cut equal chords. It may be one circle or it may be two circle, congruent circle. Electric circle, congruent circle means circles of same radius, same diameter. Then congruent, in case of congruent circle also, the same thing. You can just if two arcs are equal, then chords will be equal. If two chords will be equal, then arc will be equal. This is if it is also applicable for same for two congruent circles. Okay, congruent circles. That means whatever else. So then, if arcs of two equal congruent circles are equal, they cut equal chords. If so, here if two if chords of two equal congruent circles are equal, they cut equal arcs. If this is what opposite of this in case of congruent. If chords of two equal congruent, two equal or congruent circles are equal, they cut equal arc. Congruent circles. So draw two circles of equal radius. O dash. A, B, P and C, D, Q. So these two circles, let these two circles are congruent. That means equal. That means radius are equal. So circles will be congruent. Radius and diameter will be equal. So what it is saying? Arc. It is saying that if chords of two equals congruent circles are equal. Chord means chord AB, chord AC, CD. Chord AB, chord AB equal to chord CD. Then it's telling that chord AB arc circles are equal, they cut equal arc. That is arc A P B will equal to arc C Q D. Got this point? If two chords are equal, then the arc of APB and CQD are equal. How you can prove it? You can prove it easily. Take a paper, draw two circles of equal radius, and then draw two diameter, two chords AB of equal length. If two chords of equal length, then cut the papers along the chords. Now match both the pieces of APB and CQD. You will find it equal. Then we are going to learn theorem 6. Theorem 6. What theorem 6 is telling? Theorem 6. So, if two arcs of the same circle subtend equal angles at the center, they are equal. If two if two arcs of the same circle of the same circle if two arcs of the same circle shorten equal angle at the center, equal angle at the center, then the center, they are equal. Then if two arcs, then the two arcs are equal. Are equal. This is the theorem 6. So now in a circle, suppose two arcs, let let it O. Okay. O and two question, what it told? Two arcs of same circle, subtend equal angle at the center. Two arcs of same circle. So arc, let A, B, another 2 point, A point, B point, then another two arcs C and D. So now arc AB and CD. Two arc of same circle. It is of same circle. Two arcs of same circle. Subtend equal angle at the center. What angle? This arc AB subtend at center. What? This CD subtend angle subtend at center. Let this angle and this angle. Let it theta, let it beta. Okay. So two arcs AB and CD subtend equal angle at the center. That is the angle AOB, that is theta, E will be equal to angle COD. How to prove it? To prove angle AOB is equal to angle COD. Given, what is given? AB equal to CD, isn't it? So consider these two triangles AOB and OAB and OCD. Consider these two triangles. What? Triangle OAB and triangle OCD. So in these two triangles, what it is given? OA equal to OB. OA equal to OC. OA equal to OC. Why? Radius. Then and OB equal to OD. OB equal to OD. OB equal to OD. It is also radius. Then another is AB equal to CD given. AB equal to CD. It is given. So now these two triangles are, what will happen? These two triangles will be congruent. So triangle OAB is equal to triangle OCD. These two triangles are congruent. OAB equal to OD. So this implies, what it implies? On what basis it is congruent? SSS. This implies angle opposite to side AB and CD. Angle AOB is equal to angle COD. Got it? So now angle AOB equal to angle COD. That implies theta equal to beta. Got it? So it is proved now. So if chords are arcs are equal, if two arcs of the same circle subtend equal angle, if two arcs of the same circle subtend equal angle at the center, then arcs are equal. Sorry. What I have done, I have taken arcs are as equal and prove it that it subtend equal angles. But it is given that two arcs of the same circle subtend equal angles at the center, then the arcs are equal. So you have to prove that arcs are equal. So this is not given. This also you can take as a theorem. So I am just omitting this. This is not given. This is not given. So angle AO, he told that subtend equal angle at the center. That means angle AOB, it is given. Angle AOB equal to angle COD, it is given. So this is given means, it is given means these two triangles are equal. Now on what basis it is congruent? Similar. These two triangles are similar. Now side angle side. Side angle side. Okay. So two angles are equal, which implies that AB equal to CD. That means if the angle theta equal to beta, if 2 and theta, that is, it is given, theta equal to beta is given. So theta equal to beta is given means the angles are congruent. OA, OC is radius, OB, OD is radius, angle AOB, angle OCOD given. So theta equal to beta. So now triangle OAB and triangle OCD, OAB and OCD are congruent, similar. So the opposite side AB equal to CD. Now we look at it. They are similar triangles. So and they cut also equal chords. So chord, if arc is equal, then chord will be equal. Let this point Q, let this point R. So AQR, AQB. What is this? these two AB equal to CD. AB equal to CD. That is AB is what? AB is what? Chord. So arc, if chord will be chords are equal, then corresponding arc will be equal. We have already studied it. So arc A Q B is equal to arc C R D. Okay. So now we have proved it that the theorem 6, if two arcs of the same circle soft and equal angle at the center, then the two are then if two arcs of equal angle soft and equal angle at the center, they are equal. Then they are equal. Then the arcs are equal. So now we are going to learn another theorem. Theorem 7. What this theorem? If two arcs of a circle are equal, they subtend equal angle at the center. If two arcs of a circle are equal, they subtend equal angles at the center. Equal angle at the center. That means arc is given, two arc of a circle are equal. It is given. You have to prove that the angle subtended at the center are equal. I think we have already done that. Okay, let's do it again. A, B, C, D. Let AB and CD two arc and it is center O. If two arcs, it is given that two arcs of a circle are equal. If two arcs of a circle are equal, they subtend equal angle at the center. So what is the angle it is subtend at the center? Arc AB and arc CD. It's already, I proved it. If two arcs of a circles are equal, two arcs are equal, opposite that already you have studied. Here it is given arc AB equal to arc CD. It is given. What is given? Given arc AB equal to arc CD. And we have to prove that angle AOB equal to angle COD. We have to prove angle AOB is equal to angle COD. Previously it was given that this soft angle is equal, then arc will, we have proved arcs are equal. Now arc is equal, it is given arc is equal. So now these two triangles, consider the triangle, consider the triangles triangle OAB and triangle OCD. In this triangle, two triangle OA equal to OC, OB equal to OD, and is given AB equal to CD. These two are equal because radius of a circle, and it is given. So these two triangles are what became? It became congruent. So triangle OAB is equal to triangle OCD, which means its opposite to an opposite angle of the side AB and CD will be equal. As AB and CD are equal, so opposite angle will be equal. That is angle AOB is equal to angle COD. Got it? Very simple, isn't it? Now, you have to note something. If a circle that is arc APB, let this is P, point P, let this point is Q, okay, PQ. So, arc APB is equal to, if in a circle is center O, for the arc APB, A equal to arc CQD, arc APB equal to arc CQD. Then what it implies? Already I have learned. If arc are equal, then chord will be equal. Then AB equal to CD. And angle and its subtend equal angles at the center. Imply that angle AOB equal to angle COD. Okay? Angle AOB equal to angle COD. So, AB equal to CD, angle equal to subtend angle equal. And if arc APB arc are equal, then angles are equal. If arc, condition 1. Then condition 2, if arc APB is equal to 2 times arc CQD. Then also it is proved that, then also you can say that angle AOB, subtend angle will be 2 times angles COD. And third is arc APB, arc APB is equal if is to arc CQD if it is equal to 5 is to So if I have any ratio, 5 is to 7, if R could be in any ratio, then subtend angle will be in the same ratio. So implies subtend angle, that is angle AOB is to angle COD equal to also 5 is to 7. So if R could be in a ratio 5 is to 7, the angle will be in a ratio, same ratio, 6 to 7. If another thing, just recall. If n-sided regular polygon, if n-sided regular polygon is inscribed in a circle, then the angle subtended by each side or arm of this polygon at the center of the circle is 360 by n. If n-sided regular polygon is inscribed. What do you mean by inscribed? Inscribed means within the circle. N-sided regular polygon is inscribed in a circle. Then the angle subtend angle subtended by each side, that is arm of polygon, arm of the regular polygon, each side of the regular polygon, the angle subtended by each arm or side of the regular polygon of this polygon at the center of the circle is equal to 360 by n. Regular polygon, it is saying regular polygon. You have learned that regular polygon means what? Equal sides. Sides are equal. So angle subtended by it is 4. So this is center O. O, around O, what is how much degree? 360 degree. So each angles, now this angle is divided into 4 equal. As it is a square, regular polygon, it is square, let it is a square. So all these angles, theta 1, theta 2, theta 3, theta 4. So theta 1 plus theta 2, theta 1 plus theta 2 plus theta 3 plus theta 4 equal to 360 degree. Into it, 360 degree. Suppose it is 360 degree. Since I have taken 4 sides, so angle subtended by all are equal. So 4 theta equal to 360. Suppose it is n-sided, for 4-sided. It is for 4-side polygon. For n-side polygon, theta equal to, here theta equal to 360 by 4. Here similarly 360 degree by 4 is the number of sides. So number of sides is n, or n side polygon, 3 equal to 360 by n. Got it? So in next we'll see some examples and some exercise, and you also try yourself doing some exercise. I think you have understood everything. You can analyze yourself and do the exercise. You try to do it. If you have any doubt, you can just comment me. I'll answer it. I'll also explain to you personally also. Okay, this is what I can offer you. Thank you.